Bonjour, Mesdames, Messieurs, dear colleagues. I'm glad to present you the Aval du Futur program and the fuel cycle development in ORANO related to this program. That story all begins with the French government commitment to pursue the nuclear industry, and moreover, in link with the confirmation of the construction of a new series of EPR2, the necessity to renew the back-end nuclear facility at La Hague, which are needed to recycle the spent fuel, and moreover, prepare us to go to a full closed cycle by the end of the century. This decision was taken during the Nuclear Policy Council in March 2025 with four main topics. First one is implement a life extension resiliation program to extend the lifetime of the current facilities, to project a new MAX manufacturing facility at La Hague Seed that should start by 2040, launch a project on new storage facility at La Hague to be commissioned by 2040 also, and a project for a new spent fuel reprocessing plant that should be commissioned by 2045, 2050. So that's a big challenge that was presented to us, and we had to answer it. And to answer it, ORANO has set two complementary programs. The first one dedicated to the life extension and resiliation program under the recycling business unit management, and the second one, the Aval du Futur program, that is a brand new organization reporting directly to our CEO that will take over the construction of all the new facilities. You have on the map a kind of scheme of how the facilities dispatched on the site. You have on the right part the whole facilities on the east side of the site, and the new facility, green, on the west side of the site. Just a few words to start on the life extension and resilience program of the existing assets. It is clearly something that is needed because one of the key goals we have is to maintain the continuity of the recycling of spent fuel nuclear in France. So to secure the fact that we will be able to pursue this service during the construction phase of the new facility, we had to secure the lifetime of the old one. We had originally a program that was targeting a lifetime extension up to 2040, and the aim we had in this new program is to extend it beyond 2040, going up to 2060. With a two-leg approach, first one is to improve the continuity of operation by reinforcing the current long-term continuity approach that was already undercut, but a clear, strong reinforcement. We have a deep increase of the people involved in that program now. And moreover, to develop some investment in order to secure the redundancy or the maintenance of some key elements, and that's what we call the investment in resilience. So these clearly two legs that will secure the fact that we will be able to continue operation of La Hague with a target on 2060 and MELOX 2050 and more if possible. So, and that's clearly key because it's this continuity of operation of the facility that will allow us to give the time to build the new one, incorporating some innovation. Regarding the Aval du Futur program, it is to design, build, commission new capacities to pursue reprocessing and recycling beyond 2100. So it's something quite amazing. We are looking to build some facilities that will be in operation the next century. So it's a clear challenge for us. With the first one, that is a new unloading and wet storage facility that will be seated south of the site. You have the orange mark with an initial capacity of 6,500 tons of spent fuel storage and to be commissioned in 2040. A second pool will be put in operation about 2 years later with the same level of capacity, so giving nearly 13,000 tons of capacity in the early 2040. The second one is the reprocessing facility itself, with the commissioning that should be around 2044, 2050, depending on the lifetime extension capacity. And the third one, that is a modular MOX fuel fabrication plant that should be commissioned in 2040. So that's clearly the target. But with a little more detail, you'll see what is the industrial scheme we propose for these facility renewals. First of all, one of the key roles of these renewals is to offer us a flexible modular plant that will be able to adapt itself to the evolution of the fuel cycle. Because clearly, as we are targeting something that is far by the end of this century, we don't know exactly what will be the size of the number of reactors we'll have to serve, what will be the fuel cycle that will be implemented, meaning multi-recycling, mono-recycling, or something else. And so we need to build something that will be flexible enough to adapt to the evolution of the system in the time. So it will be composed of the reprocessing facility of around 1,200 tons of capacity, with, as I said before, a first step by implementing the storage pool. Then a first reprocessing module could be of half the capacity, 600 tons, that will be commissioned in 2045. And then the second one that will be put in operation a couple of years later. The key differentiator of this facility compared to the existing one is the fact that the lifetime will be 80 years, and that's quite a challenge also, because current facility have around 40, 50 years of operation, a target. So it's clearly a challenge. And the second challenge we have is to be able to recycle spent MOX fuel at an industrial capacity. And the target we have is 200 tons per year of spent MOX fuel reprocessing, in order to demonstrate that we are able to close the cycle, including with the MOX fuel. So open the path to the multi-recycling, either in a LWR or in a fast neutron reactor. So that's something very important, and the key differentiator of this new facility compared to the old one. For the MOX fabrication plant, so we target to have a 170 tons of MOX fuel capacity that will be at the first step equipped to manufacture 140 tons. So we don't start full capacity at the very beginning because the need is not clearly there, but it's a way to protect ourselves. If we move to multi-recycling, we will have to increase the capability of the MOX fuel, and so we want to preserve some room to be able to do it. That's the mainstream. And above those main streams, we have two options. One option in the reprocessing part to reprocess some specific fuel, I will say, which are non-standard. So that's the name of the facility is TCNS, Traitement des combustibles non standards. I'm sorry for that. So basically, it will be high PU content fuel with low solubility. So have a kind of demonstration head in order to process those fuel and also to get some data in order to prepare ourselves to reprocess the fast neutron reactor fuels. Second option, it's a MOX fast reactor, a fast neutron reactor MOX fuel manufacturing. Small size, it's 10 tons per year, so it's more a pilot line. But in order to feed what could be startups or demonstrator for the fast neutron reactor reactors. So we have those two options. Clearly, they are not mainstream, so they will take place if we are able to have a business plan that works or if they are financed. But our intent is to be prepared to implement them because we think it could serve the path to go to a further closing of the fuel cycle using the fast neutron reactor. Key challenge, as I said, is to maintain the continuity of recycling activities. That's why we have this big schedule with overlaps. Clearly, the existing facility with a new one, and the idea is to keep enough room to secure a sufficient ramp-up before shutting down the old one, so to be sure they were able to reach the nominal capacity before shutdown. So we see that for the reprocessing, basically the switch will occur between 2050 to 2060, and with 10 years of advance for the storage pool, because as every new, reprocessing facility in the world, you start by the pool because you have to cool the spent fuel before reprocessing them. So first the wet storage and then the reprocessing. For the MOX fuel, the switch will be between 2040 to 2050 and the latest possible, but it's basically what is targeted now. How to achieve this? That's the Aval du Futur program. And to do that, we are preparing ourselves by mobilizing some engineering resources. So as you see, we are around 400 people today or nearly tomorrow, I would say. So it's a strong ramp-up because we were only 100 last year. We target to be 700 next year, so nearly doubling the number of people working in our engineering team and at the program level. And the peak should be around 3,000 somewhere in 2030. So it's a very sharp ramp-up of our resources in order to be able to achieve this very, very challenging program. We are also reinforcing our own capability by setting some partnership, and we have a nice signature yesterday. Maybe you assisted, but with a pool of partners that will be the cornerstone to develop our partnership and to help us to ensure this ramp up, because 3,000 is just for us, but the ramp up is much sharper than that at the end. And so we need a lot of partners and reliable and strong partners in order to secure our success. So it's not only preparing our engineering team, it's also prepare the physical work. And so the work has started on site. And we have started to prepare the area, and we have to free this area in order to build our new facilities, and that you have the gray buildings that has to be dismantled. But before dismantling them, part of them are still in use. So we have to relocate them, before being able to destroy them. So that's the process that is started already. We have already 2 buildings we started to dismantle, and we are starting to build 2 new facilities to relocate the storage house and some maintenance hall. The idea is to free all this space, all this space, so it's a 45-hectare area, and to be able to develop our new facilities with, as you have seen in the previous snap, the unloading and the storage facility, the MOX manufacturing plant, and the rest of the reprocessing plant. So that's why, as you see, on this map, it's a schematic one for sure. But we have the room to build everything. The room to deploy the construction phase is a little more complex, and we are working to have some remote places to help us to develop this construction phase. So that's our program. And this program is clearly aimed at preparing the fuel cycle for the future, meaning adapting to new challenge, new requirement also, because we have APR2 fuel, we want to reprocess MOX fuel, we want to prepare for multi-recycling if it is decided, and and develop the performance, the overall performance of all the facilities in order to improve our economics. So it's clearly a new world that we are preparing to support new nuclear reactor, and firstly, the first of them is the PR2 fleet of EDF, but not only, also our foreign customers, but also supporting SMR and OMRs to emerge and provide them a fuel cycle solution, because there is no reactor future without a fuel cycle. Prepare the transition toward a closed fuel cycle, and clearly it's the way to contribute through the option we have. It's clearly a way to prepare for a fast neutron reactor fuel cycle in the future, and do all this for French customers, but also for our foreign customers. So we are in the middle of the pairs, meaning you have the existing facility in red that are what we are performing today. It's mono recycling, so it allows us to save some natural uranium, and 20 to 25% if you account the uranium recycling also. And with clearly key differentiator, it's a way to optimize the final volume for the deep geological disposal. It's a way also to reduce a lot the radiotoxicity of the waste we have to dispose at the end. So it's one of the key things and the reason why we implement this recycling strategy in France for years and years and years now. We are in the perspective to develop the next step, the green step. It is the Aval Futur facilities that will allow to implement the multi-recycling. Multi-recycling will allow to increase the natural use saving, going up to 40% of saving by recycling the MOX fuel, and reprocess all the spent fuel, all type of spent fuel, either MOX, ERU, reprocessed uranium fuel, or natural uranium fuel, and stabilize the fuel inventory. That means that you don't have the continuous increasing of the spent fuel to be entering store. You are able to stabilize the inventory of the spent fuel. And prepare, in that sense, the final step if you want to go to a fuel closed cycle by increasing progressively the quantity of plutonium that is circulating in the cycle, reprocessing the MOX fuel. So prepare for that a new generation of facility or some adaptation of the facility we are developing to be able to develop a real closed fuel cycle with generation 4 reactors. That's what I wanted to present you today. And so I will be ready to answer any question you have. It was too complicated, or it's just after lunch?
So thank you very much for the presentation. I'm Lorenzo Mottura from Edison, Italy. Are you planning to involve also other countries in the development of this plan? So in order to share the investments and to create something which is beneficial for all the European nuclear industry?
For sure. We believe that the French suppliers won't be enough to build this facility. We will have to build it with the support of all the industrial capability, most probably in Europe and even beyond Europe. This is for the construction phase. Then we are open to any contribution. If someone wants to contribute to the financing, we are open to that, really open. And moreover, we are open to any foreign customer as long as the fuel is compatible with our specification at the entrance. But so, yes, clearly it's something that will need international cooperation and that will be dedicated to be open to any foreign contribution, for sure.
Hello, thank you for your presentation. Are there any major innovations that you are planning to implement in LAG 2 compared to LAG 1, such as a process or whatever? And could you give us or provide us an estimate, rough estimate of the overall cost of this program without financing cost?
On the first part, the reprocessing process is the reprocessing process. So there are not so much flexibility in the process itself. Implementation in the process will be quite different. That's quite obvious. Either by we change some of the technology, and we are not defined clearly yet what could be changed and what should not be changed. It's something we are working on. But maybe it's not the main change. The main change will be on the architecture of the facility itself. Because clearly, the operator of today are not the operator of 2100. So we'll have to adapt and prepare ourselves to a new generation of operator, and maybe it won't be operator at all. So we are working on all those streams. It's a very beginning, but we have some workshop to force us to think a little out of the box and see what is the meaning of having a facility operated by the end of the century. Because clearly it could not be the same as the one of today. Thank you very much for your attention. If any question remains, we are on the booth.